Hi guys, it's Miss Jackson. I'm going to walk you through this week's lesson. It's going to be super similar to last week's lesson on two-step conversions, but this week we're going to add in volumes of a gas. Before we get going with the video, be sure that you've got out your notes page. Hopefully you were able to print it off or copy down what you needed from the Schoology lesson. You will need a periodic table, you will need a pencil, and you will need your calculator. If you go back to look at these notes without the video, we're going to begin on slide number 12 today. So go ahead and get your materials ready before we start. When we look at volume as it pertains to moles, one of the things that you need to keep in mind is that we're actually only talking about volumes of a gas. So these volumes that we're going to look at, that we're going to talk about, don't relate to anything you would measure out in a graduated cylinder. They only apply to the things in the gas phase of matter. Okay, so think balloons, think bubbles. These are only going to be gases. Okay, and you should remember from our lesson on unit conversions that 1 mole of a gas is equal to 22.4 liters at STP. So if we're working with a volume of a gas, we're going to add that into our conversion chart here, and now we're going to add in this top prong of our little wheel. Again, keeping in mind that 1 mole of a gas is always 22.4 liters, but that's only going to be at standard temperature and pressure. But that's all I'm going to give you. So you're good to go for that. All right, so our first example, okay, we're going to convert from volume to mass. And pay particular attention because I really worked hard on these slides. I think you'll notice. We're going to look at converting the 12.74 liters of nitrogen dioxide to grams. That's what I understand when I see mass. I think grams. So I'm going to continue on. Okay. First thing we're going to do is we always start with what we're given. All right, so we were given 12.7 liters of nitrogen gas, and that's going to be our beginning conversion factor. Okay, so the next thing that we're going to do, these are two-step processes. So step number 1 is we're going to convert our liters into the moles. And so my next unit is going to have to convert those liters into the moles. I know that 1 mole is equal to 22.4 liters. The liters go on bottom so that they will cancel out, and that leaves the mole on the top. So that is step number 1. So it's just like last week, convert to the mole. Step number 2 is going to be going from moles into the grams that we were asked to find in our problem. So now I've converted the liters I originally had to the mole. Liters converted to the mole. Now I'm going to take my moles and I'm going to convert it into grams. So my conversion factor, I have to put the moles in the denominator to cancel the moles on top. The 46.01 grams that you see here is the molar mass that you would get if you added up the mass of nitrogen plus the 2 oxygens. Remember, we've learned how to do that in a previous lesson. You can go back in this slideshow. There is a video link that will remind you how to do that if you have forgotten. So now what I do is I multiply everything across the top. It is best if you put parentheses at the beginning, then multiply everything, and then put a final parentheses at the end. Then you divide it by what's on bottom, 22.4. The most important set of parentheses are in the bottom. Parentheses, 22.4, close parentheses, equal. And then I can click here for my answer. So be sure that you've taken the time to calculate it on your calculator. Pause the video if you need to. I'm going to click my answer. And the final answer is 26.17 grams of water. For our next problem, we're going to be looking at converting liters into, molecules into liters of a gas. So on this one, I have 2.64 times 10 to the 24th molecules of carbon dioxide, and I want to know how many liters that is. Okay, so just as before, we're going to start with what we have been given. Yep. So we're going to start with 2.64 times 10 to the 24th molecules of carbon dioxide because that's what the problem gave us to begin with. Okay, now this is a two-step problem. Remember, if I don't have moles and I wasn't asked for moles, then it is two steps. I was given molecules and I was asked for liters, so this is two steps. So step number one is going to be take those molecules and convert them into moles. So to do that, I'm going to use 6.02 because that's how many molecules, 6.02 times 10 to the 23rd molecules in every mole. And you can see that my molecules will cancel if I put my conversion factor in this order. So now I've converted the molecules of carbon dioxide into moles of carbon dioxide. And now I'm ready for step number two. Step number two is to take those moles that I just converted to, and I'm going to convert them into liters. So to do that, I'm going to use the molar volume of 22.4. I know 1 mole of carbon dioxide gas is equal to 22.4 liters. Notice again that I put the unit I wanted to cancel on the bottom so that it would cancel my moles. And that left me with liters of carbon dioxide. So now I'm finished. I have converted from molecules to moles and moles to liters. Pause the video, calculate an answer, and then check it against what I have. The answer for this problem should be 98.23 liters of carbon dioxide. So there you have it, ladies and gentlemen. Those are some examples of two-step conversions going from particles to liters or liters to grams. It's the same concept as last week. We just added in the volume of a gas. Watch this video as many times as you need to. You can go back and review all of the slides. There are several more examples in the slides that work just like this one. Don't forget to email or pop into my virtual conference time from 10 to 11, Tuesday through Friday, if you've got questions. Oh, miss you guys. Hope to see you soon. Bye.